Hello, my wonderful environmental science students. We're going to talk about water today. Now, just a big disclaimer to get us going. We are not going to do the topic of water justice today, but we are going to get into some really important water related info, particularly as it relates to irrigation methods. And we'll see why irrigation specifically is so important in a little bit later. Um, but our enduring understandings from Unit 5. When humans use natural resources, they alter natural systems, right? But we can mitigate, not eliminate, but mitigate that impact through sustainable use. And that's the kind of the lens through which we'll look at water use today. Please try not to fall asleep, but do read from the Miller textbook, chapter 13 in its entirety. Lots of good info. All right, so let's talk about water, its properties specifically. Now, I'm going to assume that most of you understand that most of the water on the planet is actually not fresh water. Most of it's in the form of salt water in the ocean. All right. Um, Now, the reason the ocean is salty, we'll get to here briefly, but it begins with this idea that water is actually never pure in nature. Basically, as soon as water is exposed to the air in the atmosphere, it's going to dissolve some carbon dioxide, CO2. It'll dissolve some oxygen and some nitrogen and other gases. All right. Um, as soon as it comes in contact with the surface, it'll dissolve like trace amounts of various minerals, etc. All right. Now, those minerals get carried into the ocean, in the water through rivers and runoff and so on, right? As water evaporates out of the ocean, the water leaves, but those minerals stay over time. More and more minerals get carried to the ocean. Ocean becomes salty over time until it reaches its equilibrium point at which uh, the salts being added through rivers and streams are removed through mineral formation, etc. All right, but the ocean's salty. In fact, on average, it is approximately 3.5% salt. Right? Now, not exactly the same as the type of salt you put on your food. So that's sodium chloride, which might also have some iodide in it, which is an important nutrient, right? Sea salt is actually large amounts of sodium chloride, much like your table salt, but it also contains like magnesium and calcium, potassium, and other things. So sea salt's actually a little bit more nutritious in a sense, maybe, because it has some of those other trace minerals that would be important to us. All right. So, composition of seawater, 3.5% salt, sodium chloride primarily, but also some other dissolved salts. Notice that calcium and bicarbonates and other things like that for shell formation are going to be in there. Um, Now, because water is so easily dissolved, lots of materials, it's actually really easily polluted, which is why water pollution is one of our primary topics in environmental science. All right. Now, 97.5% of the water on the planet is salt water, so not directly usable by us, although there are processes we can use to remove the salt, right? We mostly rely on this 2.5% that is actually fresh water or really low salt content. Now, of that 2.5%, almost all of it's locked up in Greenland and Antarctica. So we're really left with less than 1%, about half of a percent, right, of water that's actually available to us as fresh water, right? But it turns out that even that just measly half a percent is still a stinking lot of water. All right. Now, um, traditionally, right, so going back, a century or so, right, most of the water that we accessed, right, for the purpose of irrigation and so on, came from the sky in the form of precipitation, or we pumped out of, surface water and so on. All right. So it is important to understand that precipitation is by itself an important part of how we get water for the purpose of irrigation and drinking and so on, because most of the water that feeds our surface water, right, comes from the form of precipitation. All right. Um, so we can look at our typically dry areas around the U.S. So we have our desert west over here, particularly in the southwest, and our rain shadow deserts in Washington and Oregon and so on. Okay. Um, Now, if we look at how we use water in the U.S., right? So primarily, right, we use a lot of water industrially, mostly for like the production of power and electricity or for cooling. Okay, but irrigation in the U.S. is also a really big user. Public water only makes up about 13%. Okay, um, now if we look at this kind of public water supply, this 13%, right? What do we use water for in our households? Toilets, believe it or not. The flushing of water down our toilets is the biggest, one of the biggest users of our water. Clothes washing, uh, showers and so on. Uh, Drinking, right? It's a pretty small percentage, right? Dishwashers actually are pretty efficient appliances, by the way. We'll come by that later. But all right. Um, but it is important that, like, yeah, we should conserve water around your house. But the most important places to conserve are for power production and in irrigation. All right, globally, by the way, might as well bring this up because I did put it in nice big bold print. Globally, irrigation makes up the lion's share. Not as true in the US, but globally, irrigation is the biggest user of fresh water. All right, now let's look at trends in available water, right? So 1995, we can kind of look at the colors here. So relatively small percentage of available water use is the blues and dark blues. Relatively high percentage of available freshwater use is the browns, right? Notice the trend between 1995 and 2005, right? Water shortages are going to become a bigger issue over time as populations increase, as we overdraw groundwater, etc. All right. So the number one water problem, though, so we already said the number one user of water is irrigation globally, but the number one problem with water is that 783 million, almost a billion people, live without regular access to clean water. All right, so water is easily polluted, as I mentioned. Now, the reasons for that water pollution are actually a Unit 8 topic that we will talk about in more detail. But since we are going to be working our way into the topic of agriculture, it is worthwhile to point out that agriculture is the number one polluter of water. All right. But so understand that there's a lot of water out there, a lot of fresh water, right? Here in the US, where we actually have a lot available to us, we take a lot of it for granted. So the little meme over here on the left, right, is referring to the fact that the way in which we use water takes for granted a high availability of high quality fresh water. So, for example, the water going into your toilet does not need to be clean. We're not drinking that water, all right? But the way the plumbing systems and stuff are set up is that the water that goes into your toilet is the exact same water that comes out of your faucet, right? So the meme there on the left is referring to the fact that in much of the world, the idea that we're pumping clean, drinkable water into a toilet is somewhat outlandish. Um, you know, also the fact that, we have these sprinkler systems to grow green lawns that really serve no purpose other than aesthetics, right? Is unheard of. And in fact, would just cause crazy shock to some people in the world who treat the availability of actually drinkable water as a very, very precious resource. Okay. Um, and so we have almost a billion people living without access to that. It means there's nowhere for them to get it, even if they had money. Um, so it's a big issue, and it's an important issue to address as we move into that topic of sustainability. All right. So where are we getting our water from? For drinking, and for irrigation. Usually, right, going to be coming from one of two places. It'll come in the form of surface water, runoff, lakes, streams, reservoirs behind dams, etc., or it's going to come from our groundwater. Now, we did talk about watersheds and Unit 4, so I won't get too much into this discussion, but understand that your water that comes out of your sink in your house is likely either coming from surface water, right, as a part of the municipal water supply, the watershed here, or perhaps you are drawing out of an aquifer deep underground, pumping water up from that. All right. Now, we're going to delve into the special problem of groundwater use. So let's go to Saudi Arabia in picture mode here, satellite picture mode. Saudi Arabia is a pretty dry place. You guys ought to know that. Desert, most of it's very arid desert. All right. So the natural precipitation patterns do not support agriculture. All right. Now, if we look at Saudi Arabia in 1986, right, and compare it to 2004, notice the greening of that desert. Now, some of that is due to what we call the Green Revolution and our ability to grow plants in less hospitable environments due to you know modern agricultural techniques, right? But a lot of that is due to the fact that we've gotten better about drilling deep underground and taking water that perhaps is percolated through that soil, perhaps even left over from the previous ice age, right? That seeped through the ground and fed these aquifers. We're drilling deep down and pumping that water to the surface, right? And greening deserts through that groundwater use. Pretty cool. All right. Um, but that's not a sustainable process. A lot of these aquifers, right? They take years, centuries, millennia to recharge, right? So anytime the use of a resource outpaces the nature's ability to replenish that resource, that's unsustainable. And so we have this process called aquifer depletion occurring in much of the world. Uh, for example, if you look at the US, we have moderate to critical aquifer depletion in much of the world. Now, here in our own little corner, right here in Walla Walla, we are really smart with water use here. We'll probably talk about that a little bit in class. Uh, but much of the planet, right, in the U.S. especially, is experiencing this process of water aquifer depletion, pulling the water out of the ground faster than nature can recharge it. None of that is more true than the special case of the Ogallala Aquifer. Now, this is enormous, right? This is water left over from the last ice age, right? These big, huge glaciers that covered much of North America, you know, about 30 to 40,000 years ago. Uh, as those glaciers melted and retreated, that water seeped underground and left these huge reserves of water deep underground, right? And right there in the Midwest, the breadbasket of America, we've been able to tap into that huge, huge aquifer, right? And grow a ton of corn and wheat, right? All kinds of grains to feed people, not just in the US, but all over the world. All right. But so it is one of the world's largest groundwater deposits and it's depleted, right? Very rapidly, 40 times faster than that rate of recharge. Unsustainable, right? And in some locations, they've actually had to just, uh, bail and leave because it's no longer economical to pump that water out of the ground. All right. Um, so if we can't find a better way to use water or a more sustainable way to use it, right? These areas where we grow corn and wheat, just crazy amounts, acres and acres and acres of that stuff. If they run out of water, there's going to be some issues to address there. All right. So when we overpump groundwater, what are some things that might happen? All right. Well, we do get this process of subsidence. So if you go to the Central Valley of California, where they grow lots of vegetables, all right. The pole here is actually showing this slow sinking of the earth. You have to understand that these aquifers deep underground, the water, right, that's intermixed with the sediments is actually a part of the structural integrity of that ground. And when we pull the water out, we're leaving lots of void spaces between rocks and sediments, right? And the overlying weight of that ground works to fill in those spaces, and the ground sinks as those spaces become voided. All right. So you can look at the change in elevation over time. That's called subsidence. Now, slightly scarier, well, actually a lot scarier and much more sudden, right? And this happens most commonly in places like Florida, are actually these sinkholes that like basically just swallow up entire houses, open up. And that's basically like a really sudden collapse of the overlying strata. Too much groundwater has been pulled out. All right. Now, in coastal areas, so let's say you live near the ocean, right? And we have a really urban, highly urbanized area. So there's a high uh, amount of stress on the water system there, right? We might have a freshwater aquifer, right, near that ocean, right? But there's not like an actual boundary separating the freshwater from the saltwater. All right, more of the pressure of that freshwater. Now, as we begin to draw more and more of that freshwater, right, what we're doing is changing the properties of that aquifer, so less pressure is exerted downward, keeping that salt water at bay, and eventually we start pumping brackish water, which is sort of in between ocean water and fresh water, or salt water at our pumped wells, and we can no longer use it for irrigation. All right, so overdrawing groundwater depletes our aquifers, which can cause land subsidence or sinking. It could cause sudden sinking in the form of sinkholes, or in coastal areas can lead to saltwater intrusion and making those aquifers no longer usable. All right, now surface water. So if we're pulling too much water out of rivers before they get to the ocean, for example, the Colorado River, right? In 1922, like basically the legislation that allows different entities to pull water out of the Colorado River, um, basically overestimated its total flow. All right, so it allowed a certain number of acre feet for water use. We'll talk about an acre foot here in just a second. So they overestimated the average flow, and that resulted in the fact that some months of the year, particularly when they don't have a really good snowpack, the Colorado River actually doesn't reach the sea anymore. All right, and in many cases, even if there is some water available, it's actually too salty to use at that point. Right, a big problem, particularly if you're farther downstream in the Colorado River. All right. Uh, Now, elsewhere in the world, there's the ROC over there in Eastern Europe. All right, now let's take a look at the ROC. So the ROC is an inland sea, very salty, right? But it supported, I should say, a large number of uh, endemic fish species, right? There's lots of streams, etc., flowing into the RLC. Right now, because of its location and the availability of surface water, much of that water it began to be diverted away for the purposes of agriculture. So less water was going into the RLC, right, which left a lot more water to become evaporated over time. So if we go from 1967 to 1997, there is a stark difference, right, over that 30-year period in the amount of water. Now, by this point, right, the salinity became so high that our fish, right, died off. There's just this salt content of the sea was just too high, and the fish died off. Now, let's fast forward uh, again and to 2009, and look at that, right? This entire vast sea is more or less dried up. And that's again because of the overdrawing of surface water for irrigation and so on. Pretty scary. In fact, I would encourage you guys to do some Google searches of, dried up RLC and so on. There's these ships that are just sitting on dry land now. Basically got landlocked. Pretty crazy. All right. So this takes us now to agriculture, almost 20 minutes in, and I apologize. Right, most of the water that we use globally is for the purpose of agriculture. Okay, um, so we're going to talk about four different types of irrigation. These are directly out of the CED, so these are important things to know. All right, so first of all, let's look at water rights. Ranchers, farmers, etc. They're allotted a certain amount of water each year for the purpose of irrigation, and it's usually allotted in what's called an acre feet. All right. So 1 acre foot is equal to the amount of water required to cover 1 acre of land, 1 foot deep with water, right? So an acre is just under the size of a football field, right? But if you could cover an entire acre, 1 foot deep with water, that is an acre foot. So Different farmers have different water rights based on usually really old legal buying of those water rights from decades ago in most cases. All right. Now, so when we're using that water, right, there's different methods for irrigating fields. And probably one of the cheapest, but also the most inefficient methods is what's called flood irrigation. So, if you go to certain parts of the US, you're going to have these what are called irrigation canals, which are usually lined with concrete or dirt, right? It's water diverted away from a reservoir or a stream or a lake or something nearby, and it goes through these irrigation ditches. Now, these irrigation ditches flow along these farm fields, right? And the farmers, when it's time to irrigate, will open up these little hatches and flood their fields, hence the term flood irrigation. Now, really only works well on flat land. It'd be very difficult to do on hilly land. So flood irrigation, most of the Walla area, because we do have these rolling hills, not a good way to irrigate. All right. But if we have flat land, we can do an inexpensive. Now, notice that this is just letting gravity spread the water out over a field and flood that field. All right. So no technology or equipment involved other than the irrigation ditches and these hatches to open up. All right. So it's inexpensive, but we do lose a large percentage of that water to evaporation. And it can lead to increased soil salinity, like we talked about in Unit 4. Now, the next type of irrigation is what we call furrow irrigation, which is very similar to, but more efficient than, our flood irrigation, right? So rather than just flooding an entire field, they kind of dig these channels or furrows, right? And then flood those as opposed to an entire area. Now, the nice thing about that is also inexpensive, all right? And we lose less water to evaporation than we do in just the traditional flood irrigation, okay? But still not anywhere near our most efficient type of irrigation, right? And like flood irrigation, only effective on flat ground. All right, now overhead irrigation. Now I know you guys have seen this right here in our valley. It's really common, right? So overhead irrigation makes use of these overhead sprinklers. Now notice though, right, we have some equipment, right, which adds cost and maintenance to the whole process. Now, um, so sprinkler systems, often referred to as center pivot, is a really common type. So you'll have the sprinkler attached to one center, and then these are usually wheels, right? And it can pivot around that center to create these circular fields. And that's why, like in an airplane, sometimes when you're flying over agricultural areas, you see circular fields. Those are using that center pivot system. All right. Now, they are effective on both flat or uneven ground, which makes them nice, right? Much, much, much more efficient than flood or furrow irrigation. We lose a lot less water to evaporation than we do in those systems, right? But of course, we do involve these big sprinkler systems, much more expensive and much more high maintenance. All right. Now, um, they do lose some efficiency in high winds, by the way. Now, our most efficient type, right, of irrigation is what's called micro irrigation or drip irrigation in some cases. So basically, we lose far, far, far less water to evaporation, and we're really only delivering water directly to the roots of the plants. So we have a highly, highly efficient process. Our most efficient process out there, aside from growing things in greenhouses, where we can help maintain that humidity, right? So highly efficient process is basically feeding water through these tubes, and it's just fed drip by drip to the roots of the plants. All right. Now, it's an expensive system to apply, and so it's on and the large scale, it's not very commonly used. All right. So micro irrigation is really good for growing vegetables and smaller plants, but because of the expense of initial installment, it's not as viable on the large scale. So these big, huge corn fields and wheat fields, right? Not typically fed through micro irrigation, right? Flood, furrow, or overhead irrigation, yeah. Um, but because of the big expense with micro irrigation, it's really only used on smaller scales. All right, that brings us to the end of our slideshow. Peace.